So we'll start off with a reminder here that when you declare a variable with the let binding, um, it is by default type any, which means that you're basically reverting to pure JavaScript here, where not only are the values of variables mutable, you can change the values, but the data type is changeable as well. So if I assign x to a literal of type number, I could expect the type of x to be a number and save that, and that's true. And I can also reassign it to a different value, x equals tacos, and not only does the value change, it also changes the data type. If you hover over that variable, it will tell you what it is at any particular point. So here, for example, it's any. The data type is any. Any is literally the least you can do. It is the same as declaring it like that. At least then you're being a little bit honest about it, and you're saying, I'm not going to add any type information here at all. You're telling the compiler, basically, hold my beer. I know what I'm doing, and I will be sure I don't do something dumb like X. Maybe expect X to uppercase. Notice I'm not getting any code completion here. If I run that, that's obviously going to fail because the number data type, which is what this variable has at this point in time, doesn't have a to uppercase method. If I would move that down here and obviously change the result, it will pass. But we're getting no assistance at all from the TypeScript compiler. Nothing there is preventing us from making. A good TypeScript programmer will avoid the any keyword at any cost. See what I did there? We always like to annotate our variables, our constants with data types. So for example, if I wanted to do what I did in the previous example here, but this time say this can be a number and only a number. When I assign it a value like this, of course, X will be a number. Save that, that test passes, and it'll protect me from doing something like X equals tacos. Notice now I'll get a build error. My test fails because of a build error. I can't assign type string is not assignable to type number. Now, with things like union types in TypeScript, we can say, hey, I'm okay with X being a number or a string, and it's going to be able to compile at that point. This is handy in lots of situations, some we'll get into later on, but it also gives some information to the TypeScript compiler as we're working with those variables. For example, if I type x dot here, the TypeScript language service is actually looking at the code and saying, okay, x doesn't actually have a value there, but it could be either a number or a string. So I'm going to show you the intersection of the operations that are shared in common with both number and string. And it's smart enough to know here that if I do x dot, those are all the operations that are specific to a number data type. In other words, the TypeScript language service can look at the previous line of code, say that I know at this point in the flow of the program that x holds a number value, so here's the things you can do with it. And if I try to use something that isn't a part of that, I get a build error. Likewise, after I assign it a value of a string, I can do x dot, and this is the set of operations that are valid for a string. So I could expect x dot to uppercase to be tacos. And that works. So we did a variable declaration with a union type. We could also, of course, initialize a variable, which just means to declare the variable and assign it a value at the same time. And TypeScript will use that value to the literal we assign it to set the data type. So if I say let y equal bird, it can figure out that the type of y here is a string. and it can only be a string. It is equivalent to saying string. And as a matter of fact, that's, my linter here is picking up on that. It's like, you don't need to tell me that. I can trivially, I've always thought that was funny. It's like, I don't know, a little weird, but trivially inferred from the type string. But it can be useful sometimes to actually have that type annotation, even if you're initializing it, because it allows you to do union types again. So I could say this can be either a string or an array of numbers. And it's okay with that. That's just a little warning that I'm not reassigning it. It's never being used. And I could say expect y to be bird. And if I say y equals 12, that's not in the set of valid types to assign to that variable. So I'm getting a build error here. If I say y equals 1, 2, 3, that's fine. That compiles just perfectly because this is an array of numbers. But if I put in here something that isn't a number, you can see I get a build error again. Make sure my tests pass, and they do. Okay, so let's look at the difference between the unknown data type and the any data type now, and why you should consider preferring the unknown data type anytime you're tempted to use the any data type. So if I create a block, maybe unknown versus any, and I declare a variable of type any here and assign it a value. If I tried to use that, like expect X to uppercase, that looks pretty good. GitHub Copilot writing my code for me. That works just fine. The test passes. But let's say you've been spending some time in another programming language like C# or et cetera, and you try to first off notice you don't get any real IntelliSense. There's no error here. Strings in JavaScript and therefore TypeScript don't have a toUpper method, but I'm not going to get any build errors on this. Instead, when I save it, I'm going to get a test failed because of a runtime error. ToUpper is not a function. ToUpper is actually undefined. So expect X to upper to be undefined is true. It isn't there, so we can't use the parens, the apply operator on undefined. Undefined doesn't know what to do with that. So again, the whole point of using TypeScript on top of JavaScript is to get build errors as opposed to runtime errors. So that's what we're seeing down here. If I had declared that as a unknown data type, I would have to do what I should be doing with an any data type anyhow. So if I wanted to actually check this unknown data type, so let y unknown, and I say y equals, I don't know, we'll do a different dog this time, is Fido, and I try to do something like expect y to uppercase to be Fido here. I'm actually, if I save this, and you can see the little red squiggle here, it's saying, no, I'm not even going to compile that for you. It Actually, the error's down here. The object here is unknown. You can't do anything with that until you can prove to the compiler you're doing a safe operation. So if I test the type of y as string, then it's a safe operation to do that. Y, I can see all of the string type things that you're allowed to do with a string because I've ensured to the compiler that I'm working with the appropriate data type. Outside of that, if I say expect y to upper, notice I'm not getting any IntelliSense, and I get a runtime build error here. It doesn't know what that is. So that isn't a string, so I'll just tell it to fail the test. All the tests pass. There is no opportunity for runtime exceptions because if I do something like y equals 12, we get kind of that functionality that we get with the any data type, but now I won't get a runtime error. I'll get a test failure, right? It failed because I did an assertion and told it that I should expect that to be Fido, and it wasn't a string, so it fell into my else block and failed the test. So let's get back on solid ground here, and now my test pass again.